Module 4. Module 4 deals with technologies. We don't need that. And systems. So firstly, we're looking at the function of a transport system. So what is the prime function of the transport system? And you can see some key words there. Certainly providing mobility, providing control. So can you imagine if you were driving a vehicle and you had no control of the vehicle? What causes the mobility? By some means of forces, application of forces to accelerate or decelerate the vehicle. And certainly at the end of the day, you should be able or must be able to protect the object from any damage. So that overall gives you the function of a transport system. So when we look at the basic components of a transport system, what are some of the basic elements that one would find in a transport system? And you see a few elements reflected here, like object, path, vehicle, container, way link, and so forth. And the next module will cover a little more detail on these aspects. But very briefly, an object could, for example, be a driver, occupants in a vehicle, could be goods in a container. So the path that the vehicle travels on, vehicle could be a motor car, a truck, a bus, a ship, an aircraft. So that's your vehicle. And like I said, you could have a container that is self-motorized, in other words, be able to control itself by application of forces, have mobility. On the other hand, you could have a container that's sitting on a vehicle with some object or some goods in it, okay? And it travels on a particular road, maybe rail, maybe an air passage or water, your way link. And when you do get, for example, two roads intersecting, then that's referred to as a way intersection. At a point where, for example, you are transferring your containers from a truck onto a ship, cargo ship, then you have a specific terminal for that to allow you to offload and onload. And all this is then documented in some operational plan. So there has to be some system how one goes about the whole process. And this is documented then in an operational plan. So when we talk in terms of demand for transport, we need to know what are the reasons for demand. And public transport demand, you could even refer to as private transport demand. What are the demands? And you can see there's various reasons. Some are listed on the slide: journey to work or journey to school, personal business, shopping trips, recreational trips, getting to Suncoast to do some gambling. So these are all reasons for demand. So now we have certain factors that affect the performance of any transport system, and you have some of them, or the main ones, listed here. Certainly speed. You want to get from A to B ASAP, as quickly as possible, especially if you're carrying perishable goods. And if you don't get from A to B in time, then you could have a problem. Okay, deterioration, damage to your goods. When we talk in terms of capacity, okay, I'm going to try and relate to page number in your notes, so then you have also, you can also make a note. I'm sure you all have your writing material in front of you. So if you need to make additional notes, you can do so. So we are on module 5. I'm quickly trying to page through your notes so that I can give you proper reference. So in terms of capacity, I did say refer to table, and that table that I'm referring to is on page 4 in your notes. All the table does is simply give you typical capacities for various transport systems. So for example, if you were in a car and you were measuring the capacity on a particular lane, and you measured, say, 2,500 cars per lane per hour, then you could then, and if each vehicle had maybe an average of 2 people in the vehicle, then you could work out the total in terms of capacity. The same applies for buses, for trains, for aircraft, by simply looking at, so if you had 600 buses per lane per hour and you had 20 people on average in each bus, then you can work out from there a total of 12,000 as your capacity. So it's very self-explanatory, and that information then, as I said, is on page 4. Then with cost, one needs to take into account the various costs. Of course, the most important or the most highest cost is the capital cost, the actual building of your road or the building of your rail infrastructure. That's where the bulk of the cost comes in. And then you have cost for operating your vehicles, operating your train, your buses, maintaining the roads, maintaining the rail structure, and so forth. So that falls all under cost. When we talk in terms of comfort, yes, certainly the design of a vehicle plays a very important role in that. How much of leg room you have, whether it's in a motor car, whether it's in a coach, whether it's in an aircraft, the seating arrangement, the seating pattern, how comfortable is it. Some transport modes offer catering services, or like if you're in an aircraft, how good is the lighting, how good is the air conditioning system or the heating system. So all that then relates to the factor of comfort. Reliability, yes, and I think at the previous lecture I did touch on the reliability, and I touched on the accessibility of the service. So if you missed a train, for example, how long do you have to wait for another train to arrive? How reliable is the service? The expected time of arrival, say on an aircraft, is at 10 a.m. in the morning. How reliable is it? Does it arrive at 10 a.m. or is the flight delayed? Does your transport system break down very often? So these all fall under reliability. And then finally, the last factor you have there deals with safety. And with regard to safety, it's not only the physical aspect, the personal as well. So physical, I mean, I'm sure you don't want to be in a transport system that's prone to collision, often collision. And one could relate this to the number of accidents on the road and the transportation systems that are commonly involved in these collisions. Is it the private motor car? Is it the bus? Is it the minibus taxi association? I mean, the minibus taxi. I'm referring specifically now to road. The same could apply to other modes, whether on rail, water, air, and with regard to personal as well. You don't want to be in a train, for example, and get mugged, or in your motor car and even get hijacked on your driveway or whatever. So you can see all that falls under the safety factor. So it's very self-explanatory. Then you will see there's some information there on advantages and disadvantages of existing system. And I said refer to page 5 in your notes. And so if you go to page 5 in your notes, you will see the various systems as well as the advantages and disadvantages. And it ranges right from walking. So walking is certainly an advantage, is that it is cheap to walk, but certainly very slow. So the disadvantage will be slow. And one could then compare that to, say, a motor car. That's also reflected on the table. So a motor car is certainly fast. It's much more convenient. It's a door-to-door mode of transport. Accessibility, number one. But then it does have some disadvantages. Cost factor, it is expensive. Other factors could relate to the environmental impact, emission of carbon monoxide, not good to the environment. So that will fall under the disadvantage. So yes, you can refer to table 5 on some of the other modes like the bus and the train and bicycle and so forth. So that's reflected on page 5. Then we move on to emerging advances in transportation technology. Now, when we talk in terms of emerging advances, how did transport technology advance over the years? And again, if I refer you to a previous lecture where we spoke about walking as the first form and how the invention of the motor car and the aircraft and so forth, and how that had an impact on the number of trips, OD trips, origin destination trips, the impact of that, okay, how it increased. So, and you can see how technology has increased in the transportation sector. The first one you have reflected is informatics. You know, today, if you are traveling, for example, on the N2, you have these huge digital boards that tells you, for example, accident at the Spaghetti Junction, expect delays, or if you can avoid the route, take an alternative route. So these should be real time. So you know exactly what's going on the highway or the freeway that you are traveling on. So you can see these all fall under informatics. If you're entering a car park, a mall, a car park in the mall, for example, when you enter the mall, you will see there's information there to tell you that there's 50 bays available on level 1, 120 bays available on level 2, and so forth. So that's relating to parking information. So there's many I can relate to, and these all fall under informatics. Safety is certainly very important, and some countries have really gone the extra mile with regard to safety. And I mentioned to you the other day, if you are traveling at a high speed, a warning sign comes up warning you that you're above the speed limit. So there's various radar devices that's installed to give you warning signals, and if there's an accident, to inform you that there's an accident ahead, expect delays, take an alternative route, so it's linked, so some overlap with the informatics system there. You could even have in-vehicle computer systems. Most cars today come with in-vehicle computer systems that gives you a lot of information, right? Not just the form of a GPS, but could give you a lot of other information. Some of these high-performance cars could even indicate to you accidents ahead, or if you are traveling too fast, you're getting too close to the vehicle in front of you. It has safety devices, safety beams to warn you to reduce your speed. You must have heard of the 3-second rule, where you should be traveling 3 seconds behind the vehicle in front of you. The 3-second rule for that particular speed, design speed, is based on design speed. So if you're not following the 3-second rule and the vehicle in front of you stops, then you will be unable to stop your vehicle, resulting in a rear-end collision. So these are all factors one needs to take into account. Pricing, yes, certainly in the past where the majority of your activities took place in, for example, the CBD, then various management techniques were adopted to try and avoid too many vehicles getting into the CBD area. That's because of limited on-street parking, even limited parking in your parkades. So there were various techniques and means that were adopted to try and discourage drivers getting into these congested areas like your central CBD and so forth. So for example, the parking meters here on-site, on-street parking meters could be much higher in the congested areas compared to the outskirts. Some cities have implemented automated tolls, so when you enter the congested area, it records the registration number of your vehicle, and from the registry system, okay, vehicle license registry system, it can pick up the owner of the vehicle and the address, and by the end of the month you will then get a bill for the number of times you entered the congested area, like you receive your water bill or your electricity bill, same system or procedure. So you can see there's a lot in terms of pricing. Also, one must try to look at other alternatives, then adding to the congestion in your area, your central CBD, capacity enhancement. With capacity enhancement, one should try as far as possible to use high capacity modes. So can you imagine 1,000 vehicles getting into the CBD area with only the driver? So you have 1,000 vehicles compared to a bus that may cater for 50 people. So 1,000 divided by 50, we'll do the math, how many buses then you need to get into the CBD area. You can see how much less that involves or implies. I mentioned to you also previously the BRT system, the bus rapid transit system. This is now becoming quite popular. And here in South Africa, we've already implemented the BRT system, commencing with Gauteng, then Cape Town, then Durban, and some of the other cities in South Africa. So what you are now doing, you're creating a dedicated right-of-way, a separate lane for the bus rapid transit system. And you have these hi-fi buses that allow maybe entry in the front, exit at the back, cater for disability or physically challenged commuters. So very well designed and good high speeds. So it has its own right of way. So you then traveling in your motor car and you're stuck in traffic on the remaining 1, 2, or 3 lanes. And you then decide it's much easier for you to get onto the BRT system. You will get to work much more quicker because it has its own separate right of way, free of congestion, able to maintain speeds. Sometimes they're even given priority at intersections, depending on the design of the BRT system. So, and yes, as long as you can avoid collisions, then you can increase capacity. We did speak about intersections, for example, that are capacity inhibitors. In other words, if capacity is certainly reduced at an intersection, because you are then dealing with either a stop sign, a yield sign, or a signalized intersection, and that's where you're reducing the maximum number of vehicles passing a point per hour. So you're reducing the capacity. So if you can avoid these collision situations, try and keep speed, maintain headway, that is the distance, time between vehicle, the front of a vehicle, the front, your headway is measured. We'll talk about headways when we get to traffic engineering. Then yes, certainly you can increase capacity. Pollution reduction, yes, I mentioned to you that environmental impact assessment, certainly critical. One needs to look at various ways to reduce pollution. And recently there has been strict emission standards. You know, your petrol motor cars, your diesel motor cars, the emission rate is fairly high. You can pay an additional tax for that. And in recent years, you perhaps also notice the increase in the number of electric vehicles. If you had to go back 5, 10 years, you could count the number of electric vehicles. But today, so many car manufacturers are now coming up with electric vehicles, and they're even doing further research on the battery to try and get more distance before recharging on an electric vehicle. So there's various research going on with that as well as alternative fuels to try and reduce noise on, if you take your roads, for example, on the, say, asphalt design, your premix design, what will give you minimum noise when your vehicle travels on that flexible pavement, or even if you're walking on a rigid pavement, that's a concrete design, how can one reduce the noise levels? Design of tires as well. Certain type of tire designs have different noise levels. So these are various research going on in these areas. Okay. So then let's move on from there to recent advances in transport. And we will talk about the demand and supply aspect. There are some innovative solutions to try and increase demand, to try and increase supply. okay? And you'll see there's 4 bullets on your slide there: piggybacking, fishybacking, containerization, and park and ride systems. So you can see some of the ways. So getting, for example, a truck onto a train, getting a truck onto a ship, a container onto a ship. Park and ride systems, not very common here in South Africa, but overseas quite common in some countries, where you, for example, park your vehicle on the outskirts of the CBD. So there's a parking system created, designed, very safe car park where you can park your car and then get onto a bus or a monorail or a rail system that takes you straight into the CBD. So instead of 20,000 cars getting there, you do that by means of a high capacity mode. So you get onto a train, a bus, or a monorail, and that brings you back to your car. And like I said, it's a properly designed system, very safe to park your vehicle. And if you've been reading through some of these innovative solutions, advances in transport, you will see there's also mention of a kiss and ride system. Kiss and ride system where your wife or your girlfriend drops you off at a dropping point, gives you a kiss and sends you off onto a train or a bus, right? So it's not a parking lot, it's a drop-off zone. Drop you off at that zone, and that's the terminal where you have all your buses and your rail system. So there are various innovative solutions. So we said we did mention demand-orientated solutions and supply-orientated solutions. So there are various solutions, a few listed here, not confined to these, by maybe reducing 4-day working week. One needs to compare that to the production. Are you still achieving the same production? So there's a lot of homework one needs to do if you are trying to implement the 4-day working week. Staggering your working hours certainly has taken off in some other countries. I know Australia, the Victorian model I spoke about, one of the components that they have introduced is staggering working hours, daylight saving. So there's various ways you could implement this. It could be implemented by maybe some companies adopting to commence work at maybe 9 a.m. and then finishing work at 6 a.m. or 7 a.m. And other companies may implement starting work at 7 a.m. and finishing at 3 p.m. So there's various ways one could look at. And by simply staggering your working hours, what are you doing? You are now spreading out that morning and afternoon peak, AM and PM peak. You're not getting that maximum peak that you would have had if all companies started at a common time of 8 a.m. and finished at 4:30 p.m. or whatever. So you can see by staggering your working hours, you are now evening out, spreading the peak, the AM and PM peak. Dispersion of workplaces, that has taken place itself over the years. Again, if I go back many moons, most of the work or employment took place in the CBD area. Now you have various industrial areas that have come about. The Dubai Trade Port, you've got the Riverhorse Valley complex. So by dispersion of workplaces, you're also now separating your traffic to different areas. Hence, reduction in congestion, reduction in peak, and so forth. Reduction of travel through advancements in telecommunication, use of cell phones, teleconferencing, use of internet, email. In fact, COVID took care of a lot of this recently, isn't it? How many of you are working remotely, not at your workstation, working from home, via email, via internet, via MS Team, via Zoom, and so forth. And that certainly has relieved traffic on the road. In fact, many companies are even considering maintaining this remote working, provided they are achieving the same output. At the end of the day, if they are still achieving the same output, the work gets done. Some employers then work round the clock. Yeah, I'm one of them. You may be receiving emails from me at 1 in the morning and so forth. I work round the clock. I'm still doing university work. At midnight, I'm editing a doctoral thesis or a master's dissertation that needs to go out for external examination. A lot of that gets done between 11 p.m. and 3 a.m. in the morning. So that's what demand, supply-orientated solutions. And you have various sort of fuel bullets reflected here, filling the gap between cars and buses. So there's various systems, and a lot of this, again, many of these systems or solutions apply to overseas, but you can see now in South Africa as well, we didn't have the Uber system many, many years ago. You can simply pick up your phone and dial a ride, call for an Uber. Carpool system, many companies have this where you combine and even privately get your colleagues from your workplace. So 4 of you get into one vehicle. So use one vehicle this week and then the next week another vehicle. So you save on fuel as well. And at the same time, also by having these systems in place, you can have further advantages, for example, like reserved parking, encouraging reserved parking if 2 or 3 occupants are in a vehicle. But as a single driver getting in, you will lose that opportunity of reserved parking. So there's various solutions, multimodal systems we spoke about, where you, for example, travel in a metro rail, underground rail system, get to the surface, and then board a bus. Same ticket, so we refer to that as a through ticketing system. This come under multimodal systems, integrated systems. Some cities have these walkways, moving walkways, so you don't have to get onto a bus. By simply getting onto these walkways, you can get from point A to point B in the CBD. And not only with regard to commuters and public transport, this could apply to freight as well. And you can see, for example, use of pipelines, right? Certainly with use of pipelines, it has its added advantage in terms of security, in terms of safety. So you're transporting toxic, inflammable substances through these pipelines. Now, can you imagine if that was on your road system? How often do you find trucks carrying inflammable liquids, toxic substances, blowing up on your highway? It's a common sight nowadays. So by shifting them to pipelines, you're certainly improving safety and security. So, okay, that brings us to the end of module 4. So let me stop that presentation and see if I could get to module 5. Should be able to do a quick access. Okay. Should be on full screen now. Okay, so we are now to module 5. You will see there's some maybe overlap with module 4. Some overlap, some of the slides, 1 or 2 of the slides. So we spoke about the function of a transport system, giving mobility to the object without damage. We did highlight the aspect of providing control So application of forces to accelerate or decelerate. Okay. And this aspect of overcoming resistance to motion is one of the sections that you will cover in traffic engineering. Very interesting calculations on that, whether, for example, a vehicle will be able to climb a certain grade, taking into account your resistance to motion, resistance to air, and so forth. So yes, at the end of the day, you want to protect the object from any deterioration or damage. Like I mentioned to you the other day, can you imagine if you were transporting a container full of butter from A to B and you got to point B and you now have your butter in liquid form? That was certainly not the intention, isn't it? So you need to protect the butter, and one of the ways you could do that is by having a proper refrigerated container system. So technologies in transport, the most widespread form is vehicles operating on land surface. And when we talk in terms of vehicles operating on land surface, the most common type has wheels. So your wheels basically give you the mobility. It has a body that can protect the load. When we talk in terms of economic saving, yes, a lot depends on how you provide the path for the vehicle to travel on. So if you have, for example, a smooth, hard, prepared surface like a flexible pavement, good riding quality, good skid resistance, smooth, vehicle can travel at high speed, and maintaining a good speed certainly directly links to the economic factor, savings. So other factors one can consider with transport, if you're dealing with maybe rail design, then what about the friction between your rail and your steel wheels of your train? Okay, that causes additional friction as well. So one needs to take into account when designing a rail system. And that is why you'll find when it comes to rail design, your grades are as flat as possible, unlike road design. You will certainly not find a 4-5% grade on a rail track. You will find your wheels just spinning on your rail and no movement, no motion. So these are all factors that one would need to take into account when we're looking at other forms of transport like the hovercraft, the magnetic levitated systems and so forth. They are based on, for example, the hovercraft on a cushion effect that gives it its support, that gives it its control, its mobility. And when it comes to the levitated systems, it deals more on magnetic forces. So you can see there's various technologies we're referring to this. So vehicle technology from there, you can see it's not just limited to land surface. It could be in the air, on water, buoyancy of vehicles like your ships on water, reaction forces on air, aircraft. And this could also apply to, for example, freight. So you have paths created like you have open channels for flow of liquids, chemicals, pipelines, okay, liquids, gases. So these all fall under the technology of transport. So when we look at the transportation systems, and I did say that some of the terminologies I spoke about earlier in terms of way and way link and so forth, we will highlight them again, and you can see the physical components of a transportation system here highlighted for you right from the way. When we talk in terms of the way, what do we mean? So we have artificial ways like a road. So you have a proper surface path, whether it's flexible pavement, asphalt or flexible pavement, or whether it's rigid pavement, concrete construction falls under rigid pavement. And I assume you know the difference between a flexible pavement and a rigid pavement. Sure, you did this in 2A, Transport Technology 2A. Anyone can tell me what is the basic difference between a flexible pavement and a rigid pavement? Anyone? Take a guess. Difference between a flexible pavement and a rigid pavement? No guesses?
A rigid pavement is made of concrete.
Say that again. Yeah?
A rigid pavement is made of concrete.
Rigid pavement made of concrete, okay.
And a flexible one is made of bitumen.
Bitumen, you mean asphalt?
Yeah.
Okay, you're right. But there is more to it in terms of the design aspect, the flexible and rigid pavement design aspect. You will find with the flexible pavement, you have superimposed layers. So you have your selected, you have your in situ material that's there, in situ material. Depending on the capacity, what we refer to as the carrying capacity of the in situ material, it may not be strong enough to build your asphalt pavement above it. So you have what we call superimposed layers. Superimposed layers, you could have a selected subgrade, you could have a sub-base layer, a base layer, and then your surfacing above it, your asphalt above it. So what is the purpose of these superimposed layers like your selected subgrade, your sub-base and your base? And note these layers have a certain, what we refer to as mod ASHO. You may have done the experiment, maximum density, optimum moisture content experiment. So you compact these layers to satisfy a certain mod ASHO, certain compaction effort or energy. And the highest mod ASHO is on the base layer. And above the base layer, then you have your asphalt layer, your premix, okay, that you're referring to. And the main purpose of your asphalt layer is for skid resistance purpose, to give you a smooth path, so good riding quality. But it's the superimposed layers under it that helps in terms of reducing the stresses due to your wheel load. So you have vehicles traveling on your road, it then passes these stresses onto your asphalt layer then in turn passes it on to the base layer. The base layer reduces these stresses and then pass it on to the sub-base layer and so forth, right up to the selected subgrade layer. So by the time these stresses reach the subgrade layer, it's much lower than the carrying capacity of the subgrade. Right? You must have heard the terminology CBR, Californian bearing ratio, that determine these stresses that I'm referring to. So as long as the stresses that's imposed on your selected subgrade layer is lower than your subbase, okay, that was an uninvited guest, a monkey. So I've taken care of him. Let's get back. So like I was saying, as long as your stresses on your selected subgrade is lower than the upward stresses, the carrying capacity of your subgrade layer, then you have no problem. But if the stresses are higher, that's when you get pavement failure. So with asphalt, then it's your stress reduction due to depth, where you have these superimposed layers like your base, sub-base, selected layers. With the concrete slab, your rigid pavement, it's the concrete slab that does the function of stress reduction. So you don't need the superimposed layers, the design of your concrete slab. You've done concrete technology, I'm sure you've done that. It does the function of reducing your stresses, okay? The beam and slab action. So that's the basic difference, flexible and rigid. They have their advantages and disadvantages, but we're not going to go through that. With railway design, now with railway design also, we have similar to asphalt and concrete, similar to flexible and rigid, we have what we call a ballast system. Now, a ballast system is again similar to a flexible pavement design, where you have single-sized stones that are laid over your your subgrade layer. So you have a sub-ballast, and then you have a ballast. The ballast being more superior to your sub-ballast in terms of the crushing value of your stone, in terms of other factors relating to strength. So again, you have the superimposed layers, and on your ballast, which is your single-sized stones, you have your sleepers embedded. So you could get concrete sleepers, wooden sleepers, steel sleepers, and on the sleepers then you will have your rails fixed onto the sleepers. So that's how your ballast system operates. When it comes to the ballastless, LESS, ballastless system, that is equivalent to your rigid pavement. So with the ballastless system, you have a concrete slab that's laid, and immediately above your concrete slab, you have your rails fixed. You don't have these superimposed layers that I was referring to, your sub-ballast and your ballast, these single-sized stones that I was referring to. So you can see there's a correlation between road and rail in terms of the construction. Monorail, some of you may have traveled on one, some of you may have seen a pic of one. Maybe Google and see what a monorail looks like. So there's various types of monorails. You could have a continuous beam and the monorail fitted onto this continuous beam and traveling. It could be very often the monorail is overhead. So you're again free of traffic congestion. There was a proposal of a project many years back in Durban to construct a monorail right from the Ushaka all across the beachfront to the Suncoast Hotel. And that project apparently fell away. So that monorail then would have linked all the hotels along the beachfront. So tourists could then simply get onto the monorail and get to the Ushaka Marine World or the Suncoast Casino, whatever. So, but unfortunately that didn't materialize. So, and then of course, similarly, we have pipelines where you have distribution of gases, liquids, and so forth, oils. So those all fall under the artificial ways, and then the natural ways are your sea and air. With terminals, regarding firstly road transport, you have your bus terminals. Many of you maybe traveled from here to Johannesburg and you got to the bus terminal somewhere near NMR Avenue. In all your intercity buses are there. Or you could get to a curbside, a simple form bus stop on a curbside and board a bus. So those all fall under your bus stations. Goods terminals, yes, like you have your warehouse to accommodate your goods, your containers, unloading, reloading of your containers taking place at your goods terminal, sorting out of goods. But when it comes to railways, with railways, again, if we focus on the passenger, you have your stations, you have seating at your stations, maybe waiting rooms, maybe a restaurant. So depending on the level of service that's offered, booking offices where you can buy a ticket. So, and of course, that forms the interchange point from road to rail. You could have that as well. Goods, yes, where you have certain sheds, warehouses, yards, goods yards, marshalling yards. So you have, for example, a rail system that gets your trains with your goods onto the warehouse. You may have covered rail design, I think, in 2A. So you would have dealt with terminologies like switches, turnouts, crossings, where you have given priority by a simple switch. Your train will then be directed to maybe the right-hand lane or rail or straight ahead by simple switches. And then if we're looking at air transport, yes, your airport, certainly the main link from, say, road to get to your airports or from rail to get to your airports, the main link. And you will notice that your airports, certainly the design of your airports are very important. has to be as flat as possible, well drained. You don't want water ponding on your runway or your taxiways. So very important and flat as possible. Wind direction is something else that's part of the design to get your trains, to get your aircraft off the ground. And with the air transport, the essential services include engineering, operating, and commercial. With engineering, it's more the maintenance factors, refueling. With operating, we're referring to your air and ground traffic control. And with commercial, that deals with your passengers, booking facilities, reception area, other facilities. Then coming down to sea transport, with sea transport, you have your harbors. That's your main haven, a place of shelter for your shipping. And certainly your channels to the harbor should be free of any obstruction to allow ships to get in and out of the harbor. Your port is where your passengers or good transfers take place between your sea and your land. Okay. So again, safety, you can see the need for safety to load, unload, reload. And then you also have your container ports for all your containers. Some of you may have traveled through the Bayhead area and noticed all the containers stacked. Some waiting to be loaded onto ships, cargo ships. So your carrying unit then are your aircraft, your vessels, road vehicles, railway trains. They are all your carrying units. With road transport, passengers certainly the first priority, where you have your commuters, public passenger services. And very often, if you're looking at road, then in this case, provided by your buses and your minibus taxis here in South Africa. If you look at the public transport split. So the next time you have some time, get onto the eThekwini Transportation Division of the eThekwini municipality, and you'll see there were some surveys done. Even the survey that we carried out a few years back is posted there, and you can see the public transport split. When I say public transport split, I'm referring to split amongst the buses, minibus, taxi, and rail. Okay, so now I'm talking road and rail here. And which would you have expected to be the highest in terms of commuter usage? Rail, minibus, taxi, or bus? What would you expect the split to be? Which one being the highest? Any guesses? Should be able to pick that up from daily observation.
Sorry, sir, just repeat the options.
The options are minibus, taxi, bus, and rail.
Minibus.
Yes, you are correct. Well, this survey was done a few years back and it showed, and I think even if you look at current survey, it will still show your minibus, the highest percentage commuter usage is a minibus. It was then followed by bus, and the last happened to be the rail. Sad enough, because the rail is a high capacity mode, but the patronage on your rail system over the years have declined for various factors. And I mentioned some of them in the past, like safety, like accessibility, frequency of service, and so forth. So that is why you will find that the National Department of Transport have set aside huge sums of money for research into this area to try and get rail back on the map.
Sir?
Because, yes, Robert?
Sorry, sir. Would the ideal situation be the other way around? In other words, railways leading with buses afterwards and then minibus? Or is it different for each country and areas?
Well, for South Africa, the main aim, the objective is to try and get rail perhaps the highest, to try and get rail. And the main reason to try and get rail back, rail was at one stage the highest, it was in terms of the split. and over the years it has declined. And the main objective or reason to try and get rail back as the #1 public transport service provider is because of the infrastructure. You have this very expensive infrastructure that's in place already, that's underutilized on many rail lines, many rail networks. And the other very important point is the capacity. And I did mention to you at the previous lecture, if you were to take a train with 10 or 11 coaches and check what's the capacity for each coach and work out how many passengers you are transporting all at once in one train. So it's a high capacity mode, and again, very important, it has its own right of way. It's free of congestion. So it's not adding to the congestion on your roads. It's not contributing to the congestion together with your private motor cars, your minibus taxis, your buses, your motorbikes, your trucks, and so forth. So, and that is why I was saying huge sums of money has been set aside by the National Department of Transport to try and see how we in South Africa can make rail more efficient, more effective, safe. And that is why I even mentioned to you that the Gautrain project is certainly a success story. Many professional businessmen and businesswomen are using the Gautrain from Sandton Station all the way to Pretoria, Rhodes-Hall or wherever in Pretoria, because they know if they travel on the Ben Schoeman Highway, the same trip could take them 4 or 5 times, time-wise. So certainly the emphasis is on rail promotion. So with road transport, yes, and then also you have your goods. And this is another big debate at present. Abnormal loads on our roads. Goods that were previously transported by rail, with the relaxation in the laws, these goods are now transported by road, which is causing huge congestion, huge damage to our pavement layers. Like I said, if your roads were built just for your private motor cars, it could last a lifetime. But it's because of the heavies that have a damaging effect on our roads. So there's a lot of debates around that as well. So with railways, then you have passenger and goods. With passenger, it could be split long distance trains, your suburban or short distance in towns like your metro networks. And I think I mentioned to you in places like maybe Europe or London, central London, you have the underground rail network. You don't need a motor car. You get onto it and it's very user friendly. You have your lines all color coded, so you know from central London, maybe from Hyde Park Station, if you want to get to Liverpool, you need to take the red line. If you need to get to Manchester, you need to take the yellow line and so forth. Very user friendly. Goods, okay, and then also with railways, you have the goods section. With air, you have different types of aircraft. You have the passenger, the cargo, or both, various developments in aircraft. So you know, with aircraft, there have been various developments also relating to speed. You must have heard many years back the Concorde, at what speed the Concorde traveled. So there's various, and of course, in terms of size, comparing your different wings from what size in terms of capacity, number of passengers it can carry. So you have various sizes of aircraft. Water transport, again, you have from tankers to container ships, hovercraft. The tankers are your bulk carriers, oil tankers, and of course other material as well, other container ships. You may have seen these container ships. So the next time you're traveling along the coast, look out at sea or around the harbor area. And you can associate with these containers with these standardized boxes on your cargo ships. So to maneuver, to give power to these various units, there are various ways. coal, oil, coal in terms of fuel, water in terms of steam. So there are various forms of motive power. Okay, so that then brought us to the end of Module 5, which then brings us to an online mock test. So this is an online mock test, which you are going to do like now. So that is why I did say to you, you should always have some writing material and your calculators in front of you. So try, and I'm emphasizing try not to refer to a worked example. Okay, if you do have the formula in front of you, then I will give you a break today to refer to the formula, but then bear in mind that in the test, you will not have the formula in front of you. In fact, you need to get familiar with the annexure. It is posted on Moodle, so you know exactly. Well, basically for test 1, you don't have an annexure attached to test 1. Test 2 will have an annexure. So therefore, test 1, you will need to know the formula. So for now, I'm giving you a break. You can make reference to the formula, but bear in mind, as I said, for test 1, you will not have the formula, so you need to know that. So the reference is given there. It was taken from a previous test, and it was question 4 on that test. Question 1, 2, and 3, I think, were theory questions. So the 3, 5, 7, 9, 13 marks. Perhaps the test was around 30, 35 marks. So let me quickly do a quick calculation here.
So I have a question.
Yes, yes.
So just to recap, the scope for the test 1 is up to and including chapter 5, module 5.
Correct. No, up to the end of transportation systems. So there's one more module, module 6.
Okay, sorry about. Thank you so much, sir.
Yeah, next week we will finish that off. So it's basically transportation planning and transportation systems. The transportation systems is up to module 6. So that's test 1.
Thank you, sir.
And I did say the bulk of the theory, unfortunately, is covered in test 1 because that's where most of the theory is in transportation systems and transportation planning. So I did say to be on the safe side, work on 60-40, 60 theory, 40 calcs. It may be 50-50, but I don't want to put my head on the block, and that is why I'm saying to be on the safe side, allow for 60-40, 60 theory, 40 calcs for test 1. And again, as I mentioned a short while ago, no annexure that will be attached to test 1. So you need to know the formula pertaining to the few calculations that we did in module 3 that covered driver and vehicle characteristics. And this question comes out of module 3, taken from a previous test. So I'm trying to work out a rough allocation. About 43% of the paper thereabout. So it equates to about 20 to 25 minutes in terms of time allocation for the question, which is more than adequate. So you now have, let's say, about 20 minutes. We'll work on 20 minutes to handle this question. I'm still staying online. And after the time allocation, you can then mark your test. And again, I'm saying to you that it would certainly be in your best interest to do the calculations. Like I said, also on Moodle, you would find tutorials posted on Moodle, as well as the memo or model answer. And it really defeats the purpose if you go straight to the model answer. Because bear in mind that in the test of the exam, you will not have the model answer. So rather get it wrong now. Do it now, get it wrong, check your answers, see where you made the mistake, and you certainly will not make the same mistake in the test of the exam. So please adopt that principle and you won't go wrong. So any calculation given to you, work through it first, then check your answers. So I'm allowing you the next 20 minutes to do this calculation, and then I'll come back online and we can then do the marking of this tutorial or this mock test. Okay, over to you. Now it's your time. You have 20 minutes. Go for it. Okay, my alarm just went off, which tells me that your 20 minutes is up. So you can get out your marking pen. If you don't have a red pen, it's fine. You could use any color pen. So you can mark your work then. See how you fared in this mock test. First question was determine the travel time of a car prior to the commencement of skidding. If the average coefficient of friction between the tire and the road surface is 0.42 and the length of the skid marks is 39 meters. A simple application of formula. You all should have picked up the formula. We went through it. So the speed then is square root of 254 F times D, and if you substituted your frictional coefficient into the formula, your length of speed mark into the formula, and you should have got an answer of 64.502 kilometers per hour. Now you will notice that in the test and in the exam, the first page of your test or exam, the cover page, it will be specific that all calculations should be kept to 3 decimal places. Perhaps I should have mentioned it earlier, but never too late. So make a note of that, that in your test and in your exams, all calculations should be to 3 decimal places. All right, so if you got that one right, then allocate yourself 2 marks. Let's move on to the next question. Suppose a car is known to have skidded on an asphalt surface, then on the adjacent gravel shoulder, where it finally came to a halt. The average length of the skid marks on the gravel shoulder is 16 meters, and the asphalt surface is 46 meters. What was the speed of the vehicle at the beginning of the skid? And you were given the drag factors for the asphalt surface, 0.39, and for the gravel shoulder, 0.52. That one carried 4 marks. So firstly, the speed at the beginning of the gravel portion, application of the formula, U1 squared is equal to 254 Fg, that's the frictional coefficient or drag factor on the gravel surface, multiplied by dg. Okay, that's your distance on the gravel shoulder, skid mark or your gravel shoulder. So simply inserting the values given gives you u squared, and to calculate u then will be the square root of 2113.280, and that gave you 45.970 kilometers per hour. So that was the speed at the beginning of the gravel portion. And then finally the speed at the beginning of the asphalt portion, application of the formula there, don't forget plus u1 squared in the formula. You need to know your formulae. So again, substituting the drag factor for the asphalt section as well as the skid mark on the asphalt surface, and that gave you U2, which is the speed at the beginning of the asphalt portion. Squared was 6670.040, and then finally the square root of that gave you the speed at the beginning of the asphalt portion to be 81.670 kilometers per hour. So if you can see the ticks there, so you can allocate a tick if you got that correct. If you didn't, then no tick for you. So that's 4.1 and 4.2, and then finally we move on to 4.3, which was to determine the brake distance of a vehicle traveling at 80 kilometers per hour prior to braking. And of course, your speed then reduced to 50 kilometers per hour after the brake pedal is released. So the average coefficient between the tire and road surface was given as 0.52. So again, note the formula. It's a difference in your speed squared. Don't forget the squared divided by 254F, your frictional coefficient between your tire and road surface. And that gives you the brake distance of 29.528 meters. And if you got that correct, then allocate yourself 2 marks. Then moving on to 4.4, determine the design stopping side distance for wet road, which has a design speed of 100 kilometers per hour and a brake force coefficient of 0.29. So, and you may recall at the previous lecture, I did mention this to you, that where the examiner specifies brake force coefficient is basically telling you that you need to use the formula pertaining to brake force coefficient, not the generic stopping side distance formula. If you use this generic stopping side distance formula, you would have got it wrong, although the answers may be close. So the brake force coefficient formula is 0.694 V plus V squared divided by 254F. And you did this in Transport Technology 2A, so it's not new to you. And simply inserting the values, you should have got a final safe stopping side distance or design stopping side distance of 205.159 meters. The other point you need to be very careful about is your units. And you know that with your brake force coefficient formula, V is already in kilometers per hour. V in this formula is already in kilometers per hour. Unlike your generic formula for safe stopping side distance, that's Vt plus V squared over 2G into F plus minus I. You all know the generic formula. There, your V in that formula has to be in meters per second, the design speed in meters per second. So obviously, the design speed will be given to you in kilometers per hour, which you then need to convert to meters per second. If you forget to do that, then obviously you're going to get the incorrect answer. And you all know the conversion factor. It roughly works out to 0.278, the conversion factor, approximately. So yes, if you got that one correct, then allocate yourself 2 marks. That brings you to the last question. The braking distance of a vehicle traveling down a grade. No, down is highlighted, down a grade. That's 70 kilometers per hour. So the braking distance is given to you, 68.082. From there, you're required to determine the grade, that downgrade. If the coefficient of friction between the tire and road surface is given as 0.323. So you all know the generic formula, but we are only referring to the braking distance. So it's the second half of the generic formula is the braking distance, D2. We're not interested in the perception reaction distance, D1. So making I the subject of the formula of your braking distance and solving for I. That's all that was required. If you solve for I, it would have given you firstly an answer, the decimal, 0.0395, and as a percent multiplied by 100, 3.95% downgrade. Okay. And if you got that one correct, then allocate yourself 3 marks for that. So you work out then, you do the maths how you fared in this mock test. So you got 3, 5, 7, 9, 13. So you got 13 marks. So you sum up your marks and divide by 13, multiplied by 100, will give you your percent for this. Get some feedback from you. How many of you clocked the test 100%? You all know that thumbs up sign. So let's see, by show of those, that thumbs up, how many of you got 100%? Be honest. Clock the test. 1. Only 1. Okay, never mind. Let's move on then to between 70, below 100%, but above 75%. And why I'm using 75% as a benchmark that dictates the distinction. So below 100%, but above 75%. Let's show in terms of thumbs up. Okay, quite a couple of you falling in that category. Okay, above 50%, less than 75%. Above 50%, less than 75%. Any thumbs up in that category? None. Okay, which tells me that 83% of you got below 50% from the feedback and the stats that you have given me. Never mind, like I always say, that do it on your own, identify your mistake. So if you didn't get the expected answers, then I would suggest for now, just take down the final answer only, just the final answer. Of course, this presentation, you have access to it, but for now, just take down the final answers and go back and do a little mock test correction exercise. Go back and tackle each question again and see if you can come up with the expected answers. Still failing if you don't come up with the expected answers, then look at the full solution. Okay, like I said, you have access to it. So that brings us to the end of today's.
Sorry, sir.
Yes.
Sorry, sir. Is this transportation systems presentation module 5?
This is module 5, yes.
So because ours, the presentation only goes up to slide 5, water transport, motive power. It doesn't have the...
Yeah, that was the previous semester's presentation, but you have the update presentation here. It's recorded, so you have access to the recording. So you have the updated presentation.
All right.
Okay, so any other questions then? Okay, if there's no further questions, then we'll call it a day. And we shall meet on Thursday, where we will look at the last module under transportation systems. And up to that point will be your test 1. So please, you can then start doing some revision towards the test 1. And then most probably we will also do a brief introduction to traffic engineering. Okay, thank you. We shall meet then on Thursday.